Hi everyone, I'm super glad so many of you are here. I see some thumbs up, so I assume you can hear me. I am Marius, I work as a developer evangelist at Twilio, and you might know Twilio as the communications APIs company. Maybe you just know us for the SMS API, and you can imagine how many of our customers used our SMS API in the past 2 years to build intelligent AI-based SMS chatbots. And I'm here to tell you what we have learned from building together with them. And so if you're here and you say, actually, I have no idea what RAG or Retrieval-Augmented Generation means, well, then you are in the right place, because I will demystify it together with you. And don't worry, you don't need a PhD in machine learning to know what a RAG is. I think the concept is quite straightforward, and if you don't understand anything for the rest of the talk and only the next 2 sentences, you already get the main idea. So LLMs sometimes can be inaccurate and make stuff up and forget important details. And RAG helps you to feed the right information at the right time to the LLM to make sure the answers are more reliable. This is like the short summary, but we'll dive a little bit deeper in the next few minutes. What do I build with RAG? Well, I thought we're here in Amsterdam, so it makes sense to build a chatbot that is about a travel booking platform. But a travel booking platform seemed a bit boring, so I asked ChatGPT, what kind of a travel booking platform could we build? And it's a special one that's only offering houseboats. So, and also ChatGPT came up with the name. Sorry, the clicker is not working. Okay, now it came. It came up with Krach the Way. You will see a short video here how the chatbot behaves. You don't have to follow in every detail. You just see it's a chatbot. I can ask it questions about availability of different houseboats, and then I can just vaguely describe like the restrictions that I wanted for 4 person and shouldn't be too pricey. And then I don't click on something. I just say, oh, I want to book the second one. I provide some information, and magically the booking is done. So this is, I think, a really smart chatbot that is probably smarter than most chatbots I've interacted with in the past 3 years. Actually, I think chatbots are an interesting case because they've been around forever, and sometimes they're smarter, sometimes they're not so smart. And it's actually a little bit like embarrassing, I think, sometimes, because if I call the hotline, the person on the other side is usually able to answer my questions within like 5 minutes or to help me. So it's not that my questions or inquiries are super special or specialized. It's just like a matter of how do we make smart chatbots that can use the tools that are also easy to train humans on. And this is something we will build with RAG. I structured my talk into 2 parts. First, the foundational part, where I will show you how you can implement this on your own with your own tools, with all open source projects, so you don't have any basically restrictions from licensing point of view. And then in the second part, I will show you how you can do the accelerated path, how you don't have to do every baby step on your own, but instead you can rely on best practices that we have seen our customers implement and some abstraction we provide on top. By the way, my clicker is, okay, it's maybe just a bit slow. I try to click a few times, and then it will work. So let's start with a kind of easy problem. I ask a chatbot, is there Wi-Fi on the boat I booked on Krach the Way? And that was the slide too far. Okay, and if I just ask ChatGPT, it would come up maybe with an answer like this one. It would not hallucinate. It would just tell me, yeah, well, I don't know that company, so please go to their website, which makes sense because the company does not exist. But let's assume the company would exist and you worked for the company and you had to build a chatbot. You probably still wouldn't want to rely on the answer ChatGPT gives, because you don't know how does ChatGPT come up with that answer. Is that based on an old document it found somewhere on the internet? Maybe it just copied the information from your competitors and it assumed it's the same for all providers in that category. So you want to make sure that it only answers the question based on your most recent information. ChatGPT does not know that, so we need to build something around that. And the easiest way to work around it is to use in-context learning. That basically just means we add knowledge in the context of the query. So here, the simple approach, I just copy and pasted the entire FAQ document and appended it to the user's question. And the LLM is smart enough to read the entire FAQ document and to pick the right answer and to adjust it to the way the user formulated the question. The problem is we cannot just copy and paste all of our company knowledge and add it to every single query the user sends, because there is something called a context window. So a context window, think of it like a sticky note for the LLM that can hold some important information that it can easily access, but there's only so much space on a sticky note. In the case of GPT-4o, the sticky note fits 128,000 tokens, and that, for simplicity, let's just say a token is a word, and you can imagine 128,000 words is a lot of words, but not nearly enough to fit all your knowledge. You might be able to fit your FAQ document and your terms and conditions, but would you be able to fit all your customer service tickets from the past in there? I don't think so. So sooner or later, you will run out of the space available in your context window. And there are other LLMs, such as the Gemini 1.5 Pro from Google, that fits like 1 million tokens, which is 15 times more, but still 15 times more that still won't scale for the number of tickets, and maybe for the tickets you have now, but not for all the tickets you will ever have in the future. So we need to find another way. And there are, generally speaking, 3 approaches how you can expand the capabilities of your LLM. The first 2 are really incredibly expensive in the way of money you would need to invest, as well as the human labor. You need entire data science teams, so retraining and fine-tuning are probably too expensive. But RAG, what this talks about, is doing a great job and will help you to achieve awesome results with chatbots that will be able to answer like the flows we've seen in the first video before. So what does RAG do? Well, there are different parts, and we go through every single step that is needed. The first one is called chunking. So you basically take the piece of text that you have and you split it into smaller text chunks. So here you see the FAQ document, and then I split it into different parts that are color-coded here. What is worth noting is that here each piece is maybe 8 to 10 words. In reality, you would do that from 2,000, 3,000, maybe even 5,000 tokens. So the chunks are way larger, and you would make them overlap. But here it would be boring, because then the entire document would just be one chunk, and that wouldn't make a lot of sense for training purposes. So this is how you form the chunks, and then for each chunk, you generate an embedding. And an embedding, to say it maybe in complicated words first, is a numerical representation of the semantic meaning of that piece of text. Now that sounds very vague. In the end, what you can think of, it's like a vector or an array of floating point numbers, and that represents the meaning of that sentence. So you would say, for example, let's think of them as a point on a map. So the point of a map for the sentence, I don't have food in my fridge, is really close to the point, I need to buy some groceries tonight. But the point for the flight from Munich to Amsterdam is about 1 hour, is far away from that. So the 2 points for the other sentences, because they have some semantic relationship, are close to each other. And then what you do here for each text chunk that you split before, you generate one embedding. And that might look like this. So you just have like some numbers, you don't really know what they mean, but for now you just take them and store them in a database. There are specialized vector stores that you can store the embeddings in, like Astra or Pinecone, but many traditional databases such as MySQL or Postgres are also capable to store embeddings. And then when you have all the embeddings from your documents in the database, you retrieve the embeddings again, but not all of them, only the relevant ones. Now, what does relevant mean? Well, you would take the query the user sends, so in our example, the question about Wi-Fi, convert that question also into an embedding, and then you ask a database, give me embeddings that are close to that embedding from the query. So just points that are not far away. You can also call them the nearest neighbors. And then because you converted the original text chunks to these embeddings, you can translate them back. So in our case, these are the relevant lines from the FAQ document. and then you can combine them to a prompt. Because up to now, we haven't used any LLM. We just used embeddings and text chunking. But now you can compose a prompt. So you would take the initial prompt from the user, which was the question about the Wi-Fi, and just say, here's also some context, and you drop whatever closest neighbors were returned by the database. And then magically, similar to what we've seen with the in-context learning before, the LLM is able to answer the questions. So we gave the right information at the right time to the large language model without all the other distracting information that is not relevant around it. And with that, it is guaranteed that you won't go over the context size that your LLM supports. Now, we still have a problem of like maybe the LLM will still hallucinate, it will make up things if there is no closest neighbor and there is no context it can provide or no relevant context you can provide, and that's why you still need some prompt engineering. For now, I have a really simple example where I say, answer the user's question, only answer the question if it's provided in the context. If it's not provided in the context, say, sorry, I don't know. Obviously, this is like not the most sophisticated prompt, but it already gets you most of the way there, and then you can fine tune, and depending on your application, you might need to modify it, add other prompts, so it shouldn't speak about competitors. But this is like the core idea that helps you to solve the problems. And then you need to integrate it, because so far this is just a program running on your local machine or on your server, but you want to make it available to your customers, right? So they can ask questions, so they don't have to call your hotline, that they can talk to you via WhatsApp, for example. And this is something you could do with an architecture such as this one. So first you would take all the knowledge you have in static files, such as PDF files, in your ticketing system, and generate embeddings from it, store these embeddings in a vector database, and then whenever the user sends a message via WhatsApp, for example, you use the prompt engineering, you convert the query into an embedding, fetch similar embeddings, and then provide everything to the large language model. And now we get to the hands-on demo, so I quickly run to my laptop in the back, but I hope you can still hear me. That's the advantage of having the headphones. And what we will do now is I will show you some code that I already prepared to extract knowledge from PDF files. So I think I don't need to ask anyone. I can see that the font size works from here. So you see I have a few documents with a FAQ document, also some general terms and conditions, this time in German, just to make it a little bit harder for the LLM, but it won't have problems with it. And then I open the knowledge.js file. So here you see I use LangChain, which is an open source project that is, has libraries in JavaScript, TypeScript, as well as in Python. And if I scroll down, in the first step, similar to what I said in the slides, I load the files. So I load all PDF files from the docs directory. And then I use the token text splitter. Here I use a chunk size of 30, and I make them overlap by 10. In reality, this would probably be more like 3,000 or 4,000 tokens. And then when I have the chunks, I store them in the vector store. And now I can basically first run my knowledge file, and while it's running, I open the questions file here. And this is the next step where I basically have one function that gets a question in. And the first part is I connect to my knowledge, to my vector store, and this time I use it as a retriever that always fetches the 5 closest neighbors. And then I define a prompt. You can see it's a really simple one. I say, you're a helpful assistant. Here's a placeholder for context, answer the user's question, and a placeholder for the question. It uses GPT-4o Mini, so a model that is really cheap to run. And then I basically combine the prompt and the LLM into a chain. That's also where the name LangChain comes from, so you can add different steps and concatenate them. And in the end, I can just invoke this retrieval chain with my question. For our purpose here, I log not only the answer to the console, but also the closest context and the second closest context before I return the answer. And all the way down there, I have a sample question where I say, can I bring pets on the boat? And if I run this question file and make it a bit larger here, you see the answer is, yes, you can bring pets, but it depends on the policy. And the closest context was basically exactly that question from the FAQ. So there is already the answer here, but I said I want to have the 5 closest neighbors. And the second closest is also interesting because it asks, can I fish from the houseboat? So you can see why this is still closed, because it uses the word fish, which might be interpreted as a pet. So the semantic relationship is clear, but it's obviously not the answer to my question. So that's why you would ask your LLM to actually find the right answer based on all the context you embed in the query. So now one thing that I want to show you is how to integrate this into a flow or into a WhatsApp conversation. So I expose this ask function here. And this is my server that basically listens to incoming messages that come in via WhatsApp. And so far, it just replies back with the same question. But now I say I want to basically reply with the answer. So I just call the ask function, pass in the question. And then when I get the answer back, I return that via the webhook. So the way I do it, I start my server on localhost. I have ngrok already running here. And that means when I go to my console and I register this webhook and I save it, all of you are now able to test this if you want. So you can scan that QR code on your phone and it will open WhatsApp with an example question. You can ask any question like which boats are available, which pets can I bring, it's up to you. And then I think I see most of you already scanned it. So if I navigate back to the code and I look at the logs, we should see, yeah, there's some people already asked questions. So this is now you asking the questions live. I will continue with the presentation, but feel free to interact with the bot while I keep on talking. So what have we built so far? Oh, the clicker is not yet listening to me. Okay, so we learned some context. We learned what in-context learning is. This is when we dump a lot of knowledge in the query, which works really well, but we're limited by the size of the context window. And the way we worked around it is that we put our knowledge into, or we split it into smaller chunks, converted it into embeddings that were stored in a vector database. And then with some prompt engineering, we already built a kind of smart bot. And this was like, I think, a really nice proof of concept that you can show your manager that really shows you the power of LLMs and Retrieval-Augmented Generation in a fast way to extract knowledge from PDF files. But as I said, this is a nice proof of concept. But there are many things that are still missing from production readiness. And that's what we've seen our customers, like, they were running into the same problem or same challenges over and over again. So we only extract knowledge from PDF files. I think it's easy to extend it to static text files, but what do you do with meeting notes, with voice recordings of meetings? What do you do with video files? All these different knowledge sources, you would need to implement different parsers for all of them. There are no guardrails, so this bot might talk about competitors. There are other limitations, such as it's not personalized, so everyone gets the same response. And with AI, it's so easy to actually customize the kind of responses and the tone. So this is something you should leverage when you build an AI bot and you want to run it in production. And it was not able to perform any action besides answering questions. So here I said updating records in your CRM, but think of a scenario where someone wants to modify an order, or they want to say, oh, actually, I moved from town A to town B. Can you please update it? LLM should be able to do it. So it cannot use any tools, and it cannot interact with the rest of your software system. And these are the problems we saw our customers were facing over and over again. And that's why we built an abstraction layer on top. We call this Twilio AI Assistants. And with them, you can build assistants that are able to solve the problems of your customers based on knowledge and tools that you provide. And you only need to provide knowledge and tools. You don't need to worry about all the other stuff around it. And you can, if you want, turn on a flag so it actually learns from your customers while they speak to it. So if the customer over and over asks about red sneakers, well, then it could memorize that that particular customer likes red sneakers. like everything Twilio does, this is built for builders. So I will show you a quick demo in the user interface, but everything that you will see is also available via an API, and it runs on our serverless platform, so you don't have to worry about scaling it and where it is deployed, and if you want to make it accessible via WhatsApp or via phone call, all of that is managed for you, and you only need to focus on the tools and knowledge. And with that, I come to the second part of my demo. I go over here. And this is the Twilio console. You can see I have a few AI assistants. I will just create a new one that I will call Devworld. And then I maybe copy and paste some nodes here. So I will have a system prompt similar to what you know from ChatGPT, where I say, answer the user's question, be a helpful assistant, and then I can upload knowledge. For now, I just upload, to save some time, the FAQ document. So I call it FAQ doc, and in the description, I can tell the AI what is written in there. I could point to a website, copy and paste raw text, connect to a vector database. So if you already have an AI project where all the knowledge is stored, you can connect to an existing one. But for now, I just say upload a file, and I upload the FAQ document here, say save source. And to save some time, I only add one more file with the catalog of all available houseboats. I say catalog, and I upload that file. I think this is the catalog. So in reality, you would probably have a system that also checks which boat is available at which time. This is the memory part that is turned off, but I already explained to you it would remember customers and their preference. And then we have the tools section. And this is the powerful part where you could say, actually, I want that my AI is able to do reservations. So I just give it a name called reservation tool, and I copy and paste this text here. That is basically the description that this tool can be used to make reservations. And then I make it, whenever the AI wants to make a reservation, it should make a HTTP post request to a webhook and follow this input schema. And the input schema is very simple here. It just has some information about the guest, about the boat, and about the stay. It's a public URL, so I don't need authorization at this point. And I just copy this URL here so that it will call this webhook whenever the tool wants to connect, or wants to make a reservation. And now I can jump to the simulator to test this. So I say my new user identity is my email. And here I would just say, hi, I want to visit AMS. And this is an LLM that I'm speaking to now. So it could basically, you can make abbreviations, you can switch language. It will be able to do that and to handle that and still provide helpful answers. So now I say I want to come with 3 friends. I can do typos even. And something cheap would be nice. Do you have suggestions? And then you see it is using the first all knowledge sources, and then it finds me some boats that it extracted from the catalog that I uploaded via PDF. So I say the second one sounds great. And now, because I specified what information is necessary to make a reservation, it will prompt me, would you like to proceed with the booking? Yes, booking, please. And now it will prompt me for the information it needs for the booking. So it says full name, date of birth, check-in and check-out date. And I can say Marius Obert, not a specific date format, I just like type it as I think LLMs would understand it. Check-in date, let's say March 20th, and for 5 nights. So I don't really give it a check-out date, but enough information so it can figure the check-out date out. And then it does some processing, and hopefully I get a reservation confirmation in a few seconds. One thing that we could do is to see if it sends, because it will send the HTTP post request to this URL, so we should see an incoming request at the same time when it makes the reservation here. But maybe the demo gods are not with me today, so let's, oh, no, it does it. You see, it's using the reservation tool. It says, I made a reservation, that looks great, and if I go over here, you see I had an incoming post request that basically extracted the information from the conversation into this payload of the request. And now the powerful part is really the integration. So I copy and paste the ID of this assistant from the URL over here in my cheat sheet application. So this just converts the ID to a webhook. And I copy and paste the webhook and replace the webhook we had previously. And now if I update the WhatsApp sender and go back to my presentation, you can scan the QR code again if you want. But it's the same code as you've seen before, so you will talk with the same WhatsApp conversation, but now to a different bot that has really production-ready capabilities. And I didn't have to worry about text chunking, what is the ideal chunk size. I could really just start uploading files. I did it via the UI, but I could have also written a script that uploads them, and then your customers are able to contact the AI assistant, in this case, via WhatsApp. But you've seen all the other communication channels are also open. So you could connect it to a phone number and speak to the assistant, and you wouldn't have to do any extra work for that. With that, I'm at the end of my presentation. I quickly want to show you the simplified architecture, so you don't have to worry about managing a vector database or how you generate the embeddings and which LLM to call. You just focus on the AI assistant, can connect it to your backend system, and then it works out of the box. And as I said, it is even capable to memorize your customers and to adjust to their specific needs and form the conversation or lead the conversation into a similar way as it led previous conversations with that customer. With that, thanks for your time. I'm from Twilio. We are right over there, so if you have questions about RAG or AI assistants, come to me and my colleagues. We're here all day today and tomorrow. Thank you.